Hello, everyone. Welcome to Istio Weekly. We're back. Happy 2022, I guess. We're back with Istio Weekly. And I have to mute myself or actually close the window because I started hearing myself with a delay. That's a good start. Anyway, we're back with Istio Weekly, and last year we ended the year with a fairly complex topic where we talked about external control plane. So what we're doing now with the first episode in 2022, we're gonna start with a more, I guess, beginner-friendly episode. I have Eitan joining me today, and he will talk about, and he'll actually explore how Istio resources get translated into Envoy configuration, and he will show a couple of Istio CLI commands you can then use to see what's happening under the covers. So one of our goals that we have for this year is what we want to do is we want to expose more of Istio to the community, but also expose Istio community members. So we have at Tetrade, we have a lot of amazing talent, and we'll continue and keep bringing them onto Istio Weekly, but we would also like to hear from you, from the community. Are you using Istio? Have you run into any issues? I bet you did. What are you doing and what are you trying to solve, and how are you trying to solve these problems? All the different things that might be interesting for other people to hear about as well. So you can reach out to us on either Twitter, on LinkedIn, or just by commenting on the video below. We'll figure out a way to get back to you, but we would really love to hear from you as well. All right, so a couple of things before we go to the main topic. There's a couple of announcements, and we have a bunch of interesting events that are coming up. First one is the ZTA and DevSecOps for Cloud Native Applications conference. It's a virtual conference that's co-hosted by NIST and Tetrade, and it focuses on, as the title suggests, on DevSecOps and ZTA as foundational approaches to development, deployment, and operational phases for achieving high assurance cloud native applications. So the conference consists of a service mesh training that's going to happen on January 26th, and then talks from Kelsey Hightower, Andre Mendez, Zach Butcher, Ronald Ross, and others that are happening on the 27th. We've also included a link in the video description, so you can click there and get registered for this conference. And either do the workshop or the talks, or just do both. We'll also be doing a free Istio Wasm extensions workshop. So that one will happen on February 3rd. It will be an hour-and-a-half long workshop that will dive into what Wasm is and how to create Wasm extensions, how to deploy them to your Istio service mesh. There's still a couple of open spots, and there's a link on the slide. There's also a link in the video description. So just click there and you can register for free. Now, a couple of more workshops, and this is the new ones that we're announcing. So on February 16th and February 17th, we're doing 2 free Istio 0 to 60 workshops. So there are 2 of them because they depend on which time zone you're in. So you can pick one or the other. Now, one note that the PST time zone one is already full. However, you can still go and register. You'll be put on the wait list, and you'll be the first one to know when we schedule new workshops. For the Asia Pacific options, there are still a couple of seats available, so you can go and grab those as well. Now, these workshops will be 3-hour workshops, and the goal of the workshop is to introduce you to Istios, to basically get you from 0 to 60. And as an attendee, you'll get a Kubernetes cluster you can use for the duration of the workshop. And then you'll use this cluster to go through a bunch of practical labs and actually try things out in practice. All right, so enough of me talking. I'll hand it off to Eitan, and Eitan will talk about, as I said, about how Istio configures Envoy. But Eitan, the floor is yours. Go ahead.
Thank you, Peter. Much appreciated. Hi, everyone. My name is Eitan Suez. Happy to be here. I recently joined Tetrade and have been spending a lot of time with Istio. and I sort of pitched this topic to Peter, and I'm can't wait to share it with you. So let's get started. So this is the topic: how Istio configures Envoy, and I suppose what I want to ask you is, this screen probably looks familiar to many of you, right? When you begin to look at a technology, where do you go? You check out the website. Oftentimes they have it getting started. I think the Istio docs do a wonderful job, and they also do a good job at sort of taking you from sort of finishing with getting started and do other tasks that are take you to different parts of Istio. And my question, which is a question that we often ask ourselves, is once we get sort of a basic understanding of a technology, how do we deepen it, right? So this is the motivation for this presentation. How do I go from an initial understanding of a service mesh after doing a few getting started exercises to a deeper understanding of Istio? What is Istio? Where does it add value? What is its function? And so on. So I thought we'd get started on a kind of inspirational, slightly inspirational method, so to speak. I'm going to skip over to this next slide here. Has anyone come across this quote? This is one of many, I suppose, well-known quotes. I'll read it to you in a minute. Perfection is finally attained, not when there's no longer anything to add, but when there's no longer anything to take away, when a body has been stripped down to its nakedness. I think that last part is a little bit overly poetic, but I find this quote resonates very much in our work. Oftentimes, whether we're drafting a message or whether we're putting together a demo, and this came to me while I was trying to think of a demo that was clear enough for this presentation. Oftentimes, the more I took out, the more clear the message was. And so this is a quote by, that some of you may be familiar with this person or not. This is a French author and aviator. He wrote the Little Prince. That's probably his main claim to fame, Antoine de Saint-Exupéry. All right, so that's our little motivation for this presentation. Let me step back over this part here, which is what exactly are we going to do? And I decided that the best way to proceed is to do this twice. Our first foray will be working through your typical Istio task, a traffic management task, which is foundational. How does that work? And then we'll rewind, so to speak, and go through it once more, but this time with an eye towards really understanding what's going on and where's all the magic, trying to figure it out and in the process we'll gain that deeper understanding that I was alluding to earlier. So let's get started. I'm gonna skip over this slide with what I call a canonical traffic example. So I'm gonna switch over to my terminal. Here we are, and please let me know if I need to make the font size bigger. I think it should be plenty big. And let me show you what I've got. So I'm on my Mac. I've got my terminal running. I've got a few files in this directory called Hello World. And I have, for this exercise, it's really stripped down to bare bones. You don't need much. You need a Kubernetes cluster. It doesn't really matter where it runs. In my case, I'm running it locally with kind. So if I do a kind get clusters, you'll see that I have a cluster called my Istio cluster. And I also have the Istio CLI installed, so we can do an Istio version. And this is also a good way to see not only that Istio is installed, but that my Kubernetes cluster does not yet run Istio. I haven't installed Istio yet, so that's probably the first thing we're going to need to do. By the way, I just noticed, was it yesterday or the day before, there was a new patch version of 1.12, 1.12.2 came out. So go ahead and upgrade if you need to, but that's a kind of a patch release that fixes a couple of security issues.
Luckily, we won't be doing any security stuff today, so we're good, right?
That's right. For the demo, it doesn't really matter.
Yes.
Okay, so if I just take a look at my namespaces, this is as vanilla as it gets. This is what I get out of the box when I install Kubernetes with kind, your default namespaces. And clearly, the Istio namespace is not there. So let's start there by by installing Istio. And so the command for that is istio cuddle install. And I'm going to pick on purpose the profile called minimal, which basically does not even bother to install the ingress or egress gateways. And that's because it doesn't really feature in this exploration that we're going to do. So we're going to press yes on that. And that goes surprisingly quickly.
Yeah,
all right.
There's pretty much nothing to install, right?
Yeah, it's just the
istiod, yeah,
and I guess TRDs and
yeah,
a few of these things. So if we look now at our namespaces, I love to verify after I do every step. I want to see that it actually worked. And so the thing that I look for here is that the Istio system namespace is present. If I run Istio cuddle version, I can also see that I have a control plane installed. And then the other thing I like to do is get pod -n istio system. What's actually running in that namespace? And here we see istiod, okay, our control plane, so to speak. Great. So now we're ready to start. The first thing we typically do in a canonical example is make sure that we have our default namespace ready for sidecar injection, right? So let's do that with we're going to label the namespace default with this particular label. And then again, I like to check. So we're going to do a get namespaces, and we can actually display the value of that label as a column. And we can see that our default namespace has been labeled. And most of us, I think, already understand the basic idea here, but just to be complete, what this does is it enables, there is what's called a mutating webhook admission controller that basically watches for deployments that get deployed to this particular namespace and make sure to inject the Envoy sidecar with every deployment. All right, so it's high time we talk about what we're going to deploy. So the first thing we're going to deploy, and by the way, both of these things that I'm about to show you come straight out of the Istio distribution. So if you download Istio, you look under samples, you will see these YAML files. So the first one is called sleep, which sometimes hides a little bit its true purpose, right? We say it's a service account there and a service and a deployment called sleep. And what does its deployment do? It's basically an image. If we look on line 55 here, a curl image, because sometimes it's useful to curl from inside the cluster. And that's exactly the reason that we deploy this thing is it's just going to run sleep. Well, basically, it's going to guarantee that we have a pod running that's going to allow us to run curl commands from inside the Kubernetes cluster.
Yeah. And one pro tip here, I'm pretty sure, I don't know if you have it. I know I have it. I have an alias set in my environment called kbash, and what that's going to do is it will actually start a pod. It will give me a terminal inside the pod inside of the cluster, so nice. I can do the same thing as this pretty much.
Okay, I like the name. It's very clear what it does, right? It gives you
kbash. Yeah,
kbash. Love it. Super. All right, so let's apply this thing, right? It's really apply-f, right? And what that ends up doing is creating our deployment. And the thing that I look for, right, that we all look for, is this ready column here, that it says the number 2, right? That basically is a confirmation that the whole sidecar injection thing is actually working, right? And now that I rerun this command, I could see that this pod is actually ready. Okay, so this guy is going to serve primarily as a client. Okay, so the other thing we're going to deploy is something called Hello World, and that's another sample that you'll see in the Istio distribution. So there's a service called Hello World listening on port 5000. But this time, what's interesting is we have 2 deployments. We see here on line 17 kind deployment, but it's a Hello World v1, and the image is a Hello World v1. And on line 45, we see the second deployment, Hello World v2. They both share the label app Hello World, which means that the selector for the service is going to select both deployments, or both pods, both sets of pods from both deployments. Okay, so let's apply this thing, apply-f Hello World. And now again, if we take a look, we see that we have a couple extra pods initializing. So single replica per deployment. Great. And then what we typically do in a canonical example is layer on the Istio specific bits. Now it's important to say that Istio is already in the picture there in the background. It's aware of these services, and its service registry is actually building up, and we'll see that later on. All right, hello world is going to finish initializing in just a minute. The next thing I want to show you then is this destination rule. Again, this is a typical sort of Istio concept. It's a custom resource called the destination rule that defines, well, two things here. I'm going to give a little less emphasis to the traffic policy, but it basically says, hey, with respect to load balancing, let's use random load balancing. But the important part here is the subsets. This idea that we tell Istio, hey, by the way, we know there's one service, but we want you to discriminate, to make a distinction between two subsets of that service. There's one, and we're going to use the label version, right, as the discriminator, and we're going to name subset 1 v1 and subset 2 v2, and it's a way to basically begin thinking about targeting each of these deployments independently, right? So let's make sure our pods are up and running. They are, and let's apply -f destination rule. All right. Great, so we've got this destination rule. It has a short name, DR. We can say, show me the destination rules. We can do a describe on it or what have you. And then the final step, the sort of nail in the coffin, is this idea of the virtual service. And that's really when we say, okay, I want to influence exactly where calls to hello world land, right? And here we have this HTTP route for the host called hello world, where we say we want everything to go to the subset v1. Okay, and we also, I mean, just for the sake of variety, I also threw in modifying the number of retry attempts if a call to hello world fails. I think by default the number of retries is 2, and I'm modifying it to 3. So to actually verify this, it may not be a bad idea to do it before and after. So what I mean by that is, let's go ahead and execute into the sleep container and do a curl on hello world world 5000, and so that's the endpoint exposed by that image, right? On port 5000, it's the hello endpoint. When we run that, let's do it a few times. You notice it's actually serving both v1 and v2. I haven't yet applied my virtual service, so the idea is that if I do it now, if I do a k-apply -f virtual service, now everything should go to v1. If we recall, let's just take another look. We said everything should go to subset v1. So if I just rerun that little exec of the curl command, everything should go to v1. And indeed it does. And that's the canonical example. So it's wonderful. It gives you all the tools. It tells you this is how you control your mesh. Just apply these custom resources, and it all just works. But then the question becomes, how does it work? Right, and for that, what I'd like to do is just kind of digress for just a minute and use kind of a little bit of a piece of paper to actually try to draw what we're seeing, or at least to make sure that we have a matching understanding of everything that's going on. So if we think of our Kubernetes cluster, what have we done? We've deployed this thing we called it sleep, right? One service, and then we deployed technically another service, but made up of 2 parts. There was a hello. There was a v1 and a hello v2, and we can think about maybe this rectangle is just the pod. Okay, so we have 1 pod of each, but inside the pod we have 2 containers, right? We have our little sleep container with a process that's sleeping, keeping the pod alive, but we know we've got the sidecar injection. We've got Envoy here, right? That's the whole idea of the service mesh, is envoys everywhere, and so we have an Envoy here, we have an Envoy there. We can label it Envoy, and then obviously alongside the Envoy we have the sort of the meat of the pod, which is the container that's actually doing the work, that's serving up the hello endpoint, right? This is the hello v1. I'll just misspell it there by mistake, and hello v2, right? And so, just to I guess go over, I think something that's sort of implied here is that all of our requests are actually happening from inside the sleep container. Remember when we did a kubectl exec with that curl command, we actually were running that curl command from inside that container. And the whole idea of the sidecar injection is, there's a lot of sophisticated things going in there, but the IP tables rules are modified so that all traffic in and out of that pod, of that container, are actually going through Envoy. All right, so Envoy is intercepting everything. So it deals with both directions, right? Outbound and inbound, egress and ingress. And that request magically makes its way to either hello v1 or hello v2, depending on the way that we've got our virtual service configured. Or if we don't have one configured, it'll look, somehow it has to figure out, at a call to hello, to the dot, default dot service dot cluster dot local. I guess that's a fully qualified name. Where should that get routed, right? And I guess historically, when people moved to cloud native, when they started horizontally scaling their applications, the immediate problem was the need to sort of insert a load balancer in between all of these things. Here we see more of a different mechanism where each envoy from the caller point of view is like a client-side load balancer. The decision is made here inside this guy. Just pick a different color. Maybe I'll color this. We want to focus on what goes on here inside this envoy, because it's the guy making the decision. Should I send a request to hello v1, hello v2? And the big question here, is where is Istio, right? Where is Waldo? Where is Istio in all this? How does it? It all seems magical, and we talk about Istio, but we don't see it in this picture. Right? This is a data plane. And I guess that's a little bit of a hint to, where is Istio? It's in the control plane, of course, right? All right, so let's move away from this this picture and then carry on. Now, in order to carry on, we have to introduce a few terms and a few concepts, because we're going to have to get a little more intimate with Envoy, right? Since Envoy is doing all of the sort of the hard work, we need to understand some of the terminology. And there's these 4 keywords: listeners, routes, clusters, and endpoints, which surprisingly well summarize Envoy. And I think this diagram does a really good job of this idea that there's some kind of a listener, right? In every web server, even if you think all the way back to like Apache web server, it's got to listen on some kind of port. Envoy is a proxy, it's a web server. And then the question is, what does it do with a request that is received? How is it going to get routed? So there's a concept of a route. And then I guess the part that takes a little getting used to is the term cluster, because oftentimes when we use the term cluster in Kubernetes context, we think a Kubernetes cluster, multiple nodes. Here, the term cluster means something entirely different. It's just a backend service. Right, and when you think of the backend service, sometimes we think of it in the singular, but it's really backed by multiple endpoints, right? If you've got 5 replicas of a deployment, you got 5 endpoints, but we think of the things logically as one. So the cluster is the logical one thing, and then the endpoints are the actual individual targetable pods that are running, that are backing this cluster.
With like IPs.
Yes, IP.
Clusters are, you can think of clusters as names, right? Just strings. But endpoints are actual something you can make a call to physically, like network address, right? Or network.
Yeah. So what Peter said, think of the name as the cluster and the IP address as the endpoint. Yeah.
Yes. Yep.
All right. So I like to also do this. To sort of repeat this idea, it's really surprising to me how well this works. If you were to just draw these 4 boxes, right, and just label them, right, and you think listener, you think route, and then, no, let me switch to black also. I didn't really mean to start with red. So listener, route, what was the third one? Cluster, yes. And the final one, endpoint. You can see, this is like a 10,000-foot overview of Envoy. You don't have to get into too much detail, but imagine again this request coming in, right? An HTTP request, and it's the listener who receives that request, and it has to, if you think, if you're familiar with Envoy, you know that there's also like an HTTP connection filter that can also parse a lot of the network attributes and the layer 7 information, but it receives this request, and ultimately you have to ask yourself, well, what do I do with it? And who answers that question? But the routing rules, right? There's a routing rule that says, okay, for this request, and there may be multiple rules that says, if there's a particular header in the request, send it to which cluster, right? So the routing rule has to make a decision on which cluster to target. And then finally, there have to be some kind of load balancing strategy that helps us determine which endpoint to select. So if we do like round robin, we might select index 0 first, index 1 second, and so on. Or if we have a different strategy, then we abide by that. So think of Envoy as essentially these 4 components, and they each are independently configured that allow you to basically tell Envoy, okay, you're going to listen on these ports, you're going to have these routing rules, these clusters, and these endpoints. All right, let's go right back here and talk about a few commands that are going to help us in doing diagnosis and looking behind the scenes. So there's a wonderful article on the Istio documentation website that introduces you to them. So I'm going to try to make a mental note to add that link. Maybe we'll put in the description afterwards. But proxy-status is one, and proxy-config is the other one. They're both Istio CLI subcommands, and we're going to be learning to use them in just a minute. And then I thought it would be relevant to also point out that there's also an experimental command called Istio CLI x describe, which, if we have time, we'll also take a look at it, which sometimes reduces some of the noise in trying to understand what's going on in your mesh. All right, so with that in mind, let's begin to take a closer look. So I'm going to start, I'll go back to my, oops, there we go. I'm going to go back to my console here. And I'm going to clean everything up. Everything I just did in the canonical example is gone, okay, or terminating, right? If we look at the pods, I'm sure that there's a kind of little grace period there that's given to all our little pods. So anyway, they're terminating. Everything will be gone. We can check, show me destination rules, show me virtual services, and by everything I mean everything we deployed. So I mean Istio is still there, right? Let's check. Okay, get NS. So Istio system is still there. Wonderful, and we can also check the labels. Yeah, the default namespace is still labeled. All right, so we're starting again, but this time we're going to do it slightly differently. I'm going to start with I mentioned the command proxy-status. I'm just going to run it, and it's at this point you should have like question marks, in your mind, like, what am I looking at? These are the headings of a table that's empty, right? And what I'm going to use proxy-status for is as a sort of a poor man's service registry, and this basically tells me that there are no services in my registry yet. That's not exactly right, but at least that's the output of proxy-status.
There's no proxies, pretty much.
Right,
yeah.
Exactly.
Yeah.
This actually lists your proxies. And we're going to have to take a minute to explain these headings for each of these columns. What is CDS, LDS, EDS? So the DS part is an acronym for Discovery Service, which is sort of the API that we can use to configure Envoy. And then the C, L, E, and R are actually the first letter in cluster, listener, endpoint, and route. So the terms we just discussed. So maybe the best way to explain this is to run it and yeah. So I'm going to watch the same command. I'm just going to run Istio CLI proxy-status, but now I'm going to watch it. Watch is a wonderful little utility that reruns whatever command you give it every 2 seconds. So it makes it kind of live, which is kind of cool. And I'm going to open another terminal, and we're going to do the same thing we did before, kapply-f sleep. And as this pod comes to life, suddenly it appears on that list up at the top. Okay. So we can conclude just by doing this very simple exercise that somehow Istio must be watching for the deployment of services so that it can update its registries. This happens transparently and implicitly in the context of Kubernetes, which is wonderful. We can also glean that proxy-status might have been designed for a different purpose altogether, which is to determine whether my envoys are configured in a way that's synchronized with what Istio's understanding of the mesh was. So, if you could imagine if there was some kind of network problem where Istio couldn't talk to your envoys, then your envoys might not be configured in an up-to-date fashion. So, but it's it serves pretty nicely as a little sort of poor man's way of looking at the service registry. And speaking of looking at the service registry and speaking of looking at things behind the curtain, it may be important for me to mention that Istio itself has a debug endpoint called registry with a Z in the end, which is a sort of a convention where we can actually hit that endpoint. Let me just show it to you. We can actually do an exec on in the Istio system. Of course, we have istiod, and in istiod we can do a curl to localhost 15014 debug RegistryZ, and what you get back is a bunch of JSON, which is kind of hard to parse. So I'm going to pass it through JQ. Oops. So I'm going to fish out just one of the names from every row in the results, basically, which is the host name, one of the fields. There we go. So what you're looking at here is what get returned in the HTTP response to this endpoint, which shows that sleep is on the list. It's on the registry. So if you want to know, there is actually an endpoint that will show you the registry, which otherwise is just sort of hidden back there, right? There's no.
Just for fun, can you just find RegistryZ and see how much configuration is there without the JQ?
Oh yeah, sure. Yeah. It's not
just so everybody gets like it's like an
yeah. And I guess what I could do is just a JQ dot, which makes it
to make it look.
Yeah.
There's way more
There's a lot of
information here. Yeah.
Right. So if you want the details, you can have the details. Yeah. Good point. Great. So we've done that. We know about proxy status. We know that Istio is aware that sleep is in the mesh, and maybe it's high time that we also deploy hello world. But I also promised another command. I mentioned that there is a command called istio proxy-config. So if you just invoke that by itself, you'll get the help for it. And its name is actually very apropos. If you want to know the configuration for your proxy, for your sidecar, you invoke proxy-config, and you have to tell it two things primarily. Well, what part of the config you want? Envoy configs are notoriously lengthy, right? And so we can look at only one part of it, like the cluster configuration, the endpoints, the listeners, the routes, or if we want everything, we do all. Now, the other part of this command is saying, well, which proxy are we interested in? And we're going to be focusing on the client, on our little sleep proxy. So the way we would invoke this command is something along these lines, right? Istio proxy-config. We want to look, let's just pick clusters. Why not? It's not a bad place to start. And then we say which pod we're interested in. And we're going to be looking at the configuration for the sidecar that's inside this pod. All right, and if you look at the output, again, you could say there's a lot of noise here, right? There's a lot of things. I didn't deploy anything yet. Where did all this come from? Well, there are things in other namespaces. There are things that, and this gives you some insight. For example, I'm just going to pick on Zipkin, right? One of the things with Istio, with service meshes that we tout is the observability, the ability to actually see what goes on, right? And so we know that Envoy plays a role there in sending all kinds of metrics to Prometheus or exposing a Prometheus endpoint. And so it's also configured with those. But what I'm going to ask you to do is to ignore all of that. Think of it as noise, okay? And we're going to run this one more time, but this time we're going to watch it, okay? And as we watch this, now we're going to deploy our hello world. So okay, apply -f hello world. And what I want to do is see does the Envoy configuration change? When we run this thing, you see it? Yeah, it just showed up. Yeah. You see it right there. A new entry showed up. So our Envoy is getting reconfigured dynamically every time we, something changes in our mesh. In this case, the change is a new service shows up. It's like, hey, I'm hello world. And now all the neighbors know about it. It's like somebody moving into the neighborhood, right?
Right. Everyone knowing, like it's
no privacy.
A neighbor talking to another, right? Telling there's a new person here.
There's a new person here. Exactly. Yeah.
It's basically knowing about, like, it's knowing about it, right? It's not saying anything. It's just, hey, there's a new service here. Here's the name, right? Here's the port. From the standpoint of the sleep proxy or the proxy in the sleep pod, it's an outbound connection, right?
Yes,
and exactly. EDS just says it's a endpoint discovery service, right? That's what it was.
Right.
So coming from there, right?
It's important to understand these columns, right? So there's the service, fully qualified domain name, the port number, which direction, is it an outbound call or an inbound call from the point of view of the sleep? Yeah. So thank you for explaining all of that. So we'll pay attention to these columns a little more closely as we go through this. Now, there's a couple of things we could do. I'm gonna pick on another istio proxy-config command, and we're gonna look at the endpoints. not the clusters. Okay. So if we look at the endpoints, we see a bunch of endpoints. Now, there's a couple of things that need to be explained here. What you see on the left-hand side are the actual pod IP addresses, and we can actually correlate those. If I do a kget pod, I think if we show it in wide form, we'll see the IP addresses, the pods, and we should be able to see that hello world v2, for example, 10.244.0.10 is actually matches that first entry there at the top. It's healthy, okay, no outliers, fine. This requires a little explanation. What is this? This is actually the name of the backend, the cluster, right? And it's it looks like a concatenated list of fields using the pipe character as a delimiter, but you can think of all of these fields concatenated together produce a unique string that allow you to target a cluster. So this is the actual cluster name from Envoy's point of view. So you can actually say, we can restrict that output. We can rerun this command. I don't know if I copied. Yeah, I did copy it into my buffer. So we can actually say, show me all the endpoints just for this cluster. Okay, this is a little bit more easy to digest. We have two, right? And we can do this watch again, maybe. So we're looking at the endpoints. And how might we influence the list of endpoints for this particular backing service? Well, we can pick one of the two deployments, right? And we can scale it. We can deploy hello world, say version 1, and pick replicas 2. And by scaling the number of replicas for one of those two deployments, we should see a new endpoint show up on the list, right? And then I can change the replicas to 1, and we should see the reverse happening. So again, Envoy is always in the know. It knows, and it's always configured with an up-to-date view of what's actually running in your Kubernetes cluster, which is great. All right, so now let's take a look at remember our destination rule. Destination rule introduces two subsets, and it'll be interesting to see how that translates into an Envoy config. So I'm going to go back to my watching of the clusters. There we go. Watching of the clusters. This thing. Remember how we saw hello world as one of the clusters? I'm gonna do a watch on that. Actually, oh, I did. Okay, it's already running. Great. So I'm gonna do a k apply -f now, just for the sake of before we do this, just for the sake of reminding ourselves what exactly we're applying. We're defining two subsets. That's the primary thing we're doing. Okay. So k apply -f destination rule, and I want you to pay attention again to that listing at the top. It's refreshing every 2 seconds. So as we apply the destination rule, something peculiar happens, right? We now suddenly have 3 backends for hello world. And the reason we have 3 is we have one for each subset, V1 and V2. And you can see that column subset has actually been filled. And then one that will still target both subsets as a whole. Like, if you still want to call all members of all deployments that match the original service, you still can. So it's kind of interesting how destination rule is translated into multiple clusters, right? So again, we can ask the question is, now show me the endpoints, right? Istio cuddle, proxy-config, endpoint, sleep. Yeah, so there's still 2 endpoints for this cluster, but there's another cluster now. Oops, that's not what I meant to do.
So this is basically a way, like we can see how does,
oops, yeah.
What does the actual creating a subset, what does it do, right? It basically creates these 2 distinct clusters, which each one of those clusters has a different set of
endpoints. Yes.
Endpoints of IPs, right? And that in the end allows you to you have 5,000 at the end. You should probably.
Oh, that's why. I didn't understand why. Okay.
Yeah.
Okay. So now we see both endpoints. Yep.
Yeah. So now they're both, but then if you do like V1 in there, right, you're only going to see the.
That's it. If we
whatever the subset is
to V1. Yeah. Exactly. Thank you, Peter. So yeah, so I had a little bit of a fumble there with my command, and we can ask the same question with respect to V2. So we notice that the V2 cluster has one endpoint, which is the IP address of the V2 pod, presumably, and then the V1 endpoint. So, and then if we again, there's also, we can still ask questions about this cluster, and it has both endpoints. All right, terrific. Now, what's interesting, and this is probably the other part of the proxy config command that I haven't shown yet, is the proxy config of the routes configuration. So if we do an istio proxy config, show me the routes. Here, I'm gonna close this bottom terminal so we have a little bit more room. Show me the routes for the sleep. What are we gonna see? Well, we see again, there are multiple routes for different listeners on different ports, 5,000. We're interested in port 5,000. That's where Hello World's running. So we're going to zero in on that guy. Name equals 5,000. And we're going to actually see everything. We want to do, we can do a -o YAML. And I'm going to pretty print that by piping it through bat, which is a wonderful little, it's like a utility that's like cat, the cat command, but it's called bat instead, which does a wonderful job.
It just does the color coding.
Yeah, it does the color coding, gives you line numbers. It makes it a lot easier to look at YAML and other things as well. So what are we seeing here? We're seeing the routing rules for what? For the listener 5,000. Notice the domains. So if you want to match Hello World in all kinds of different ways by the service IP address or by fully qualified or not fully qualified with or without port, then the routing rule is on line 29. Make sure here on line 35, make sure to send all those requests to the cluster named outbound 5,000. Notice there's no V1 and no V2 in there, and that's because we haven't yet applied our virtual service. And there on the retry policy, we see our number of retries is 2.
Yeah, and this is the domains is actually that domain section. What if you look at that, what it's actually telling you, you can use any of those domains if you wish, and you'll be able to target any of the endpoints in that cluster, right? So if you would do curl hello world, curl 5,000, default SVC 5,000, right? All of those.
It's all going to funnel through here. It's all gonna
exactly.
Yeah.
So
So if you have a typo, right, and you have only one L and hello, then
yes, exactly, it's not going to work.
It's not going to work. Yeah. All right. So So how do we affect this? Well, we know the answer. It's this virtual service. Say, okay, we want to send everything through V1, and we want the retry attempts to be 3. Oops. All right. Just a second. Okay. So K apply -f virtual service. And now we just need to look at our route again and see, well, how's it changed? And it's kind of hard to pick out, but it's you'll see it in 2 places. One is the cluster name on line 39. So you see it there. The cluster is now outbound 5,000 V1. Before it was outbound 5,000 pipe. There was no V1, no subset. And then the other thing to notice is the number of retries on line 43 has changed to 3. So we can, essentially, this is the Envoy config that matches whatever we put in our virtual service. And again, how do we test this? We do an exec, right? Okay, exec on sleep. And here's our curl command, curl hello world. I'm going to be lazy and not use the fully qualified name, even though that's not necessarily the best practice.
I guess it's fine
best typing.
If you're running locally and you're using kind and it's not actually like it's for the demo.
But we see the result. It always goes to V1. That means our policy has been applied, and we saw that.
It's pretty much what we did when you deploy the virtual service. You're kind of pinning the version down to V1. You're hard coding it, and that's what the proxy-config command actually showed as well. It's hard coded to that cluster with that specific name. So there's no way it's going to go anywhere else.
There's only one endpoint, right?
Exactly. I mean, there's one cluster, one endpoint. It's going to go there, right? The cluster name is what matters in this case, right?
So we go through this exercise. Maybe we decide to change our virtual service, not to send to V1, but to send to V2, for example, right? And as we make that change, it shouldn't be a surprise if we look at our route. We should see that the cluster name on line 39 again now says V2. So we've just redirected all requests to the V2 pod, and we can run exec command to actually see that it's going to send it to V2.
It's been 2. Yeah. Can you go back to the configuration? Like, I want to point out one more thing. The one thing that's interesting, like if you're ever wondering, like, oh, what are the default retriable status codes, the number of retries, retry policy, what is the default timeout, etc. Well, there it is, right? Like you can even run this command without applying anything, right? And you'll see like, oh, these are the defaults that that are set.
Sidecars, it comes up, yeah.
Exactly. So these are the defaults. So if you're for whatever reason, let's say your retry policy is not working the way you wanted it to work, or something's wrong, right? You can always, like, of course, you're going to start with your YAML, you'll see what's there, but in most of the cases, it's maybe the error is not going to be there, right? So what you can do next is just open up, like crack open this, the configuration, and actually see what Envoy sees, right?
Yeah, and it helps you compare your understanding of things with the reality. And sometimes there's a mismatch, and that's how we learn.
Exactly. And if you would go and change, like if you would change a timeout in the virtual service, you would see the timeout change here.
Yes. It's a wonderful learning sort of exercise. Yeah. So very much in the vein of what we're doing here. All right. One other thing that I want to do, which I have been refraining from showing you, is we could do a simple K logs, right, on Istio system. Let's look at the istiod logs. All right, I'm going to do a follow on that so that we can see. I'm going to clear that on purpose so we can have the least amount of noise. And as I edit my virtual service one last time, maybe this time we'll do something fun. We'll split the traffic between V1 and V2 with weights, right? We're going to say maybe this is a 60-40 split. 60-40. And as I save this, look at the logs from Istio at the top. Okay, so every line looks very similar, right? It's info, ADS. ADS is the aggregate discovery service in Istio. And then it's actually telling you which part of the Envoy configuration it's actually pushing. There's a cluster discovery service, a listener discovery service, and who is it pushing it to? It's pushing it not just to sleep, but also to all the other pods running in our mesh. And we care about, when we make that change, we care about the RDS push for the sleep node, right? Because we're making calls from the sleep node, and we affected the routing rules. And that's exactly what that. So that, I think, is the final nail in the coffin. It basically explains where Istio is. It's like this sort of magic guardian angel right there that's like out of sight, but it's doing its job every time. We modify our mesh, and it pushes all of these configuration changes.
It pushes it to everything, right? And this is like, I think we had an episode at some point talking about the sidecar resource, right? So what you can do with the sidecar resource, then you can actually control to which proxies you want to push this configuration to. So you can just say, I only want to publish or push the configuration to proxies in the same namespace, or this specific pod only, or other namespace, right? And that's how you can control like
the scope of
exactly. Where like the scope is the right word.
Exactly. So if you have like a population of services that span 2 namespaces, maybe you don't want Istio to publish configuration changes to other pods,
because it doesn't make sense, right? It's just like wasting time in a way, right? Also, can you also show how this looks like in like in the proxy config, like the same view we had before, but now we did like a split, right? How does this show up in the proxy config?
Right. So which part do you want, like the route or the
I think it was route, like whatever we. I think it was. It was route.
Oh yes, that's right. I forgot. Yeah. This is important.
Yeah.
So this looks a little bit different from what we've seen before, right? We've got 2 clusters, V1 and V2, under a weighted clusters field, which wasn't there before.
Yep.
And the split is 60-40, just like we asked for it. Yeah, thank you for reminding me.
And the names are different, right? And the cluster names are different, right? It's V1 and V2.
Yep.
And then the weight, and this, like if someone's wondering what this weighted clusters thing is, it's just something that Envoy knows about, right? It's part of the Envoy configuration, right? That's how you do weighted cluster or weighted traffic splitting, I guess, in Envoy directly, right?
And so this is actually a point I make at the end, but I might as well do it now, which is, do we care about how Envoy, the specifics of configuring Envoy? I mean, technically, we could be blissfully ignorant. All we need to know is how we configure Istio, and let Istio take care of the details, which is wonderful. Another thing that came to mind, which I want to bring up, Peter, is you had an interview with a Tetrade engineer who's working on something called Delta XDS. Do you remember that?
Oh, yeah. Aditya, right? Aditya.
Yeah, that's it. Aditya Pereira, I think is his name.
Yeah.
And he talked about, so when we look at the logs of pushing We were looking at the Istio logs. What was that?
I think it was istiod, right?
Yeah. So you may be asking yourself, wow, Istio is pushing a lot of information to a lot of things. And what Delta XDS is going to do is really correct that by, I don't know if it already does it or if it's going to do it, I don't know which version it'll come out in, but that's what Aditya was talking about is they're going to figure out the delta, like what changed in the Envoy configuration and change and send only a much smaller payload to each of the envoys. So maybe there'll be less pushes at the end, be smarter, depending on what you changed in your mesh. You won't be sending the full config.
Yeah. Because if you think about it, if you send if the only thing that you change in your virtual service is you go from 60/40 to 50/50, right? That's the only thing that you have to change. You have to send. You don't have to send the retries. You don't have to send the routes. You don't have to send anything. That's it's just like another layer of optimization, I guess, right?
Yes,
it's going to be like I don't think like a Istio end user will have to do anything, or operator or administrator. You won't have to do anything.
No. It'll be completely transparent.
Exactly. Yes. It'll just make everything faster. And I think depending on your scale as well, you might not even see it, right? It might be like it's not gonna it's already fast.
Yeah.
Yeah, I mean, if you have I don't know what we have 100.
Yeah, Istio has been production ready.
But maybe you'll see it if you have 50,000 services or something. You might notice it. You'll definitely notice it if you don't use the sidecar resource, right? You'll definitely notice at that scale. You'll notice, right? But anyway, it's just another level of optimization, I guess.
Yeah. Another thing I mentioned that I would show, I don't think it has much value, but let's go ahead and do it, is the istio x describe command. We can do a describe on the pod called sleep. And let's just try to understand what it shows us. This is kind of an interesting command. So one thing that it does is that, again, it's a sort of a guardian, right? It says, hey, by the way, you might consider adding a version label on your service, but this is a contrived example. Sleep is never meant to be a service that you call, but more of a client, so we can ignore that safely. But if we do an istio x describe pod hello world v1, I think this is really useful and wonderful information. So if you want to know, how things are configured vis-a-vis this pod, notice the weight 60%, that it's part of the virtual service hello world, that it's part of the v1 subset, and so on and so forth. This output is nice and small, nice and tidy, gives you all of the basic, hits all of the important points without a lot of the noise of, a multi-page YAML file that you might encounter if you're looking at your Envoy configuration. So it's a nice thing to have.
Is it only for pods, or can you target something else?
You can target also services.
Oh, you can do service directly.
Yeah. And let's see what the output for service will show us.
Perfect. Yeah, like a high level. It's almost like a more human readable version of YAML.
Bingo. Yes, that's exactly it. So it's not a bad thing to keep in your back pocket, and just be aware of it, that it might actually, it's a quick way to get at information about how things are currently configured in your mesh.
Yeah, awesome.
All right. So this diagram is supposed to be sort of a the unveiling of the curtain, showing exactly what role Istio plays in all of this. So on the left-hand side in blue, we see our Kubernetes CRDs, right? We apply DestinationRule virtual services. When you do an apply-f, we all know that gets sent to the Kubernetes API server, and it stores all of these things as records in etcd. But istiod is watching, right? It's watching for the creation or modification or deletion of any of these, so that it can update the envoys. And so there's a number of things it does. One is it acts as a translator or an adapter. And it also pushes the configuration to the envoys. And those, I think, are good things from a design point of view. And this is what I wanted to talk about. So one thing that I personally learned from going through this exercise, Peter, is how there's this very interesting, almost like yin and yang duality between Envoy and Istio on one hand. I mean, they both play their roles perfectly, but one can't live without the other kind of thing. I don't know, maybe I'm getting a little too philosophical, but that's the first thing I wanted to point out. Another one is you can almost think of istiod as kind of being almost a classic example of an operator controller. I mean, it's not an operator, but it reconciles desired state to running state, right? It actually takes, whatever you put in your VirtualService.yaml and all these other YAMLs that configure your mesh and makes them so to speak, right? So it's very Kubernetes native in that way. I already mentioned this one, that maybe it gives you a new perspective on Istio. Maybe Istio is nothing more than an adapter, right? I'm exaggerating, it does a lot more, but maybe that's an interesting insight anyway. And then this is something I've heard it said many times before, that Envoy sort of fades into the background, that do we need to know how Envoy is configured? At the end of the day, it's actually the workhorse in the back room doing all the work, but the door is closed and we don't even know it's there, right? So to speak. That's an awful little metaphor, but you kind of get the idea that Envoy sort of fades away into the background because it becomes an implementation detail. All right, and then the last thing I wanted to point out, which to me I think is maybe stands out in some way, is this observation about inversion of control. I don't know why I make this observation, perhaps because I have kind of a Java and Spring background, and inversion of control has always been a big thing there, or dependency injection. But it's a beautiful design pattern in that Envoy is completely unaware of its environment, right? It just does its job. And that's, we always talk about, single responsibility principle being a good hallmark of good design, for example. Envoy does its job, but because it has these wonderful features that you can configure it via API, that it can reload itself without, being taken down and restarted, enable a different design where we have Istio pushing configuration updates to the envoys and not the other way around, which solve in a natural way all kinds of problems. Because if Envoy had to know about Istio, it would have to fetch periodically a copy of the service registry, and then it'd have to cache a copy, and we have caching problems. Maybe it's out of date. All of these problems go away because of this inversion of control. All right, so that's the last message I wanted to sort of leave our audience with. And Peter, I'm going to hand it back to you. I think we've got a couple more slides to wrap up our episode.
I think it's just the last slide. I think this was awesome. It like gave a good like inside view of how the things have, like, everyone is just applying YAMLs, right? But they don't necessarily know what's happening behind the scenes. And it's not like you have to know. You don't have to know it. That's the whole point of it, right? Like, why would you have to go and like learn about like thousands of lines of Envoy configuration and parse through that if you don't necessarily have to, right? That's what Istio is here for, right? To take your high level configuration, use the abstractions, make it easier to understand, and then you can trust Istio that it's going to go and translate it to correct Envoy proxy configuration. But like the commands that we showed, like proxy-status, the config, right? All those things are extremely useful when you're just as like learning tools, but also as if something goes wrong and you really have to like dig deep, this is where you can go and then dig deep if needed, right? And look through the actual configuration that's generated, right? And just understand how it works.
Yeah.
All right, I don't think we didn't have any questions in the chat, so I think I asked and interrupted you enough times, so that was good as well.
Good. No, I like that. That's good. Thanks, Peter.
Yeah, but all in all, it was great. I don't have anything else. Like, if you have any, if anyone watching this has any comments, suggestions, ideas, feedback, questions, etc., you can always just comment under the video. Like and subscribe, whatever kids these days say when they go live on YouTube. You can also go to Istio Weekly. It'll just take you to our playlist. We have a bunch of episodes. You can follow us on Twitter. You can join the Slack. But anyway, thanks, Eitan. Thanks again, and we'll be back in a couple of weeks again with the new episode.
Sure, it was a pleasure.
Bye, guys. Thanks, everyone. Bye. All right, we're done.